Okay, the sun and stars. Okay, so your star features, things that you're going to have to consider are the size, the mass, the color, the temperature, and the brightness. Okay, we're going to... Okay, sorry about that. Okay, so we're going to talk about the one closest to the Earth, obviously the sun. It's 150 million kilometers away. The size is about 109 Earths lined up from edge to edge at its diameter. It contains 98% of the mass of the whole solar system, much like a nucleus would for an atom. And its mass controls all the motion of the solar system. It keeps the planets in their orbit based on the gravitational pull of the sun. Oops, let's go back. So let's take a good picture. We're going to look at a lot of different pictures. We can see a solar flare here. There's one over here. And when you think about the sun, consider that it's not really made of the phases of matter that you're used to. It's made of plasma. So it's made of charged particles, meaning it's radioactive, it's radiation. It's more energy than it is stuff. Okay, so layers of the sun, if we start from the bottom and work our way up, makes more sense. Everything out there that we know of has a core. It says it can reach up to 15 million degrees Celsius. So this is the hottest layer. This is going to be the hottest layer of planets also. This is where fusion occurs. Fusion is combining or fusing together hydrogen atoms to form helium. The next layer is the photosphere. Okay, the photosphere is what produces the light. Photo means light. And it is the innermost layer on top of the core. It's about 6,000 degrees. The chromosphere is next. It's what gives it its color. Chromo means color. So the sun is a yellow star. This is where we get the solar flares as well. It shows you the temperature. The corona is actually like the rays, the outermost layer, and it's very hot. It's also very thin. It says a spacecraft could pass through it because of how thin it is. All right, so here's another picture. You can see the corona or the rays. You have your photosphere and your chromosphere. What's important to know is that the photosphere produces the light, the chromosphere produces the color. Okay, there's just the corona, so it's what's visible during a solar eclipse. The chromosphere, this is under a solar lens so that the person looking at it isn't being blinded. You can see some of the sunspots. There's your photosphere. Again, you can see some of the sunspots. Okay. Solar winds. This is the gas that speeds out from the corona. It's the radiation. It moves out in all directions. It does consist of ions, which are charged particles. So we're talking about alpha, beta, and gamma radiation. The Earth's magnetic field, thankfully, deflects most of it. However, it does get in the two areas where the ozone layer is weak. And this creates the Van Allen radiation belts, or the auroras. The aurora borealis, northern and southern lights. It goes by several names. There's a good picture of it. Okay, and this is a picture of the magnetosphere, and you can see the two areas that are not really protected well. It's also bigger, much bigger on the side away from the sun. Okay, so types of storms on the sun. A prominence says a huge bright arc or loop. In other words, it comes up. I'm going to draw in here. You can see where it came up right here, and then it comes back down. Okay, a lot of the radiation is released into space when this happens. Here's a good picture of a prominence. Sunspots are the darker areas on the sun. This is an area that is cooler. It's not cool in any way. It's still very hot, but compared to everything around it, it's cooler. The number of sunspots is always changing, and they do kind of give us a clue as to how active the sun is going to be in that year. And every 11 years, the sun has a really active year. And every 11 years, the number of sunspots changes. This is what they look like magnified. Okay, solar flare is just another storm. It's a bright burst of light, so all of these bright bursts of light are different solar flares. It does release huge amounts of energy. Okay, it says there is evidence, these are just interesting facts, that the solar activity affects the climate of the Earth. It's not going to affect it right away. Okay, it's going to over time affect it. Every 11 years or so, there are climatic changes corresponding to the change in the sunspots. It says when a solar activity cycle stops, the climate can enter a cold period, much like the Little Ice Age of the 1600s. You don't have to write these down. These are just different facts. Okay, so what is the sun made of? It's 74% hydrogen, 26% helium. And most of the universe is also made of plasma, so it has all the same or similar composition. Even though this is rare, plasma is rare on Earth, the only example we have would be lightning. It's very common in the universe. Okay, star groups are called constellations. There are 88 constellations named. Ancient people would sit outside when it stare at the sky and tell stories, and they would name the constellations. They do appear to be moving around the poles, but actually it's the Earth that's moving. Stars do not move. They do spin around, they rotate on their own axis, but they do not revolve. They stay where they are. So we have, different ones that we see based on the summer sky, based on the winter sky, and if we're in the northern or southern hemisphere, we would see totally different constellations. Okay, most stars are part of a binary system. That means they typically are not alone. They have a sister star, and they revolve around one another only. Parallax is what we use to measure the distance from stars to the Earth. We measure it in AUs. Okay, so the distance from the Earth to the sun would be 1 AU, and we go from there. Okay, types of stars. You probably thought there were only one kind. A neutron star is the smallest star. It's actually smaller than the Earth. A white dwarf is about the size of the Earth. It gives off very little light. Main sequence is what the sun is right now, a medium-sized star. There are giant stars ranging from 10 to 100 times the size of the sun, and supergiants 1,000 times the size of the sun. There are two examples to know, Rigel and Betelgeuse. It says if one of these were our sun, we would burst into cinders. It would stretch out and reach Mars. Okay, magnitude, you have two types. There's apparent magnitude and absolute magnitude. Apparent magnitude is how it appears to us on Earth. So the brightest star may not actually be truly the brightest. The absolute magnitude is its true brightness if you were to get close to it and see its actual brightness. The Hertzsprung-Russell diagram shows the relationship between the magnitude and the surface temperature. Okay, it says which color of stars do you think is the hottest? Which do you think are the coolest? You might be surprised to know that red is actually the coolest and blue is the hottest. However, if you think of a flame, it is the same. Okay, so again, our sun falls right in the middle. Just a mediocre star. Okay, this is the Hertzsprung-Russell diagram. If you go down to 6,000 down here at the bottom where the temperature is, and you come straight up, you'll see our sun right there. And if you were to look at its magnitude, you'd say it had a luminosity of 1. Okay, how is a star formed? It's formed from nebula. This is the birthplace of stars, commonly called that. So it says, formed from nebula that compacts due to gravity, and through the process of fusion, you have the core of a star that's formed. A protostar is what we call a brand new star. It forms in the nebula. They do release lots of energy. Then the main sequence star comes. It can last between 10 billion and 80 billion years. Our sun is a 10 billion year life cycle. 90% of its life will be in this stage. They do get their energy through fusion. It gives you several examples. Then it expands itself when it runs out of hydrogen, and it becomes a red giant. So it expands itself, it's very thin. It would swallow up the Earth, and then eventually it would shrink back on itself and become the next layer, which is a white dwarf. You can see the size compared to the Earth, it's not that big. It releases very little light, so it just has this faint glow. Then it becomes a black dwarf where it no longer has any energy and it's basically a dead star. Okay, if the star started out as a supergiant, okay, if it started out really big, then it might explode and form a supernova. A supernova can either go into neutron star or it can go into a black hole. If it becomes a neutron star, all the stuff that made up the giant star is squished into one tiny asteroid-sized star. And so it's very dense. Or it can become a black hole. The gravity, it says, is so strong that even light is pulled in or gas is pulled in, nothing can escape. Okay, so here again is the life cycle of stars. So this life cycle is if it's a regular star, and then if it's a supergiant, it can become a supernova or a black hole, which ends up being supernova, which is either a black hole or a neutron. And then that leftover nebula that you see over in the bottom right will become a new star, and you get a protostar again, and it starts over. Okay, we've already talked about light years. We do use this to measure distance. Parallax we're going to talk about in class. And that is all of your notes. See you guys in class.